Now let's look at example 2.21, page 78 of your module. So look at question A. So find the volume of the solid bounded by xy plane. So this solid will be bounded by xy plane. Okay, and also the yz plane. Okay, plane. xz plane, okay, and plane z equals to 1 minus x squared, and one more plane is y plus x equals to 1. So before we find the volume, we need to construct this 3D structure. Okay, so let's focus on these two equations. So if we brought these two equations in 2D diagram, okay, 2D diagram. For the first one, z equals to 1 minus x squared. So it is a quadratic functions. Okay, quadratic function. And if according to this function, okay, this one is negative value, so your graph will be some sort like having an N-shaped curve. Okay, so you can label your graph. This is the z, this is the x. Okay, so when your x is 0, your z will be equals to 1, so you can mark one point here. And when your z equals to 0, your x can be positive 1 and negative 1. So you can mark the point. This is negative 1 and this is positive 1. Okay, so you connect this point together in the form of curve. Okay, it is a quadratic, so it will be a curve, something like this. Okay, things like that. So this one will be z equals to 1 minus x squared, and for the second one, okay, it is a straight line. So it is a straight line. If you rewrite the straight line formula, it will be equals to y equals to negative x plus 1. Okay, so the graph will be in these directions. Okay, will be in these directions. Okay, something like this. Okay, and the intersection point here will be 1, and here this is y and this is x. So when your y is 0, the x will be 1. Okay, so this one is the graph for these two plane, okay, in 2D. Next, let's move them into 3D. Okay, we have to move them into 3D. So we move them into 3D. Okay, so beside these two planes, we have the other planes as well. So this is the xy plane. Okay, I hope you remember what is xy plane. Xy plane is basically a plane which is located parallel with the xy axis. Okay, this is the y, this is the x. So the xy plane will be somewhere like this. Okay, infinite size. Okay, infinite size. And the yz plane. Okay, the yz plane will be, okay, this is the z and this is the y. So the yz plane will be something like this. Okay, just imagine its size is infinite big. Okay, something like this. Okay, next one you have the xz plane. So the xz plane, this is the x, this is the z. So the xz plane will be like this. Okay, things like that. Okay, xyz plane, sz plane. Okay, so actually this means the boundary of the 3D structure. The important part is you have to draw this plane into this 3D diagram first. So let's look at this one, zx. So this is z and this is x. So we have to transform the diagram here into 3D. Okay, so I will extend this axis in the negative directions. Okay, so after that I draw the curve. Okay, draw like this. Okay, so this one will be your curve, and this is 1, this is -1. Okay, so you can extend this structure in y directions. So meaning that, okay, now I extend my y-axis. So I draw again. Okay, and this will be easier when I draw. Okay, we'll move it here. Okay, so I will draw another one diagram. Okay, so this one maybe is the curve. Things like that. Okay, so I hope you can understand the drawing. Okay, so when you link them together, okay, maybe we'll shape something like this. Okay, so I think I will redraw it. Okay, this thing, I'm going to redraw it. Okay. Things like that. Maybe I should draw a straight line to facilitate my drawing. After that, I can delete it. Okay, so this one will be your z equals to 1 minus x squared plane. Okay, this is the plane. Okay, you can imagine it. So after that, we have the y equals to negative x plus 1 plane. Okay, so I will draw by using the other colors. So maybe try blue colors. Okay, blue colors. So you have the x and y. So in this direction, so this one will be your will be your 1. Okay, and this one is also your 1. Okay, so when you connect them together, okay, so you can connect them together by using proper line. Okay, so after that you construct a straight line. So using this one, straight line. The blue colors. Okay, no blue colors. Okay, never mind. to represent the plane. Then we draw again. So this one will be a plane. Okay, this one will be a plane. Okay, so I use the blue color line. Okay, so I hope you can see this plane. So this one represents the y equals to minus x plus 1 plane. Okay, so now you have to imagine this plane is cut by this blue plane. So you have to draw the structure again, and don't forget, okay, about these three planes. This is actually meanings, okay, the plane, sorry, okay, this actually means xy plane will be here. Okay, this one will be an xy plane. Okay, and the yz plane will be here. Okay, this is the yz plane. Okay, and the zx plane will be here. Okay, so actually this will be the portion that you need to find its volume. So you can redraw this structure again in the new 3D diagram. So you can draw it. Okay. Okay, so I can draw it. So this will be z, this one will be y, and this one will be x. Okay, so if you draw it again, here you will have a rectangle. So you will have a rectangle here. Okay, rectangle here. Okay, put the rectangle here. So after that you will have a curve. Okay, this is the rectangle that I mean. So you will have a curve, okay, touching here. So next you will have a curve, okay, touching here. Okay, since your structure, your plane is cut by the blue plane, so you have to draw this line here. So you draw this line here. Okay, and this one you just connect it to this point. Okay, so this will be the structure that you need to find is volume. Okay, so now let's refer to the equation in order to find the volume of a 3D structure by using triple integrals. So you have triple integral sign, and here you have 1 and dv behind. So in this case, we will use the Cartesian coordinate systems. So we will choose dy, dx, dz. Okay, so in this case, we have to choose what types of projection that we want to use. If you refer to this structure, okay, you can choose projection xy, okay, which we refer to this plane xy. So if you choose projection xy, so this will be the triangle that you can find in the projection xy. This is the y, this is the x. Okay, so you have to use vertical or horizontal strip technique in order to define the interval for x and y. So the interval for x will be from 0 to 1, and the interval for y will be from 0 up to negative x plus 1, which is the equation of this line. Okay, so this one will be the interval for your x and y. Next, okay, we have to define the interval for the z. So you have to assume yourself is inside this 3D structure. So when you refer down, you will see a plane which is z equals to 0. So when you refer up, you will see this surface. Am I right? So you will see this surface. Okay, so the equation of this surface is represented by, so just now when you will have lowest value 0, the equation of this plane is, you have to refer to your question. So this is the plane, right? So this will be the plane. Okay, this will be the plane. So the equation of this plane is this one, 1 minus x squared. Okay, so 1 minus x squared. Okay, so you have defined the interval for these three x, y, z. So you put them into the equations. Remember, value should stay outside. So x should be here. So after that, you have your y minus x plus 1. And then after that, you have your z, 1 minus x squared. You have 1, so this one represents the z interval, followed by the y interval, and lastly will be your x interval. Okay, so you arrange them like this. So your job now is to solve these triple integrals. So 0, 1, 0, negative x plus 1, and this thing you bring it inside. Okay, because after the integration you will have z, and you replace this thing to z. So you have dy dx. Okay, now we continue the second level of integrations. Okay, you will top up another y here after the integration. So you will have 1 minus x squared multiply minus x plus 1. Okay, dx. So at this stage, you can press your calculator for answer. So after pressing your calculator, remember when you press the calculator, you have to insert a bracket. Okay, so your answer will be 5 over 12 unit cube, because it is the volume. Okay, so this is example 2.21a. Okay, so for the same question, you can also try to solve by using different projection. Okay, remember, okay, this is the questions. So just now we choose the xy projections. XY projections. Okay, in order to solve this triple integral, you can also solve it by using the other projections such as zx projections. So let's try the zx projections. So you have to draw the view, okay, if it is zx projection. So you draw, okay, so you draw your 2D diagram. So this is what you will get when it is zx projection. Okay, you will see this structure, okay, you will see this curve, and this is actually equations from the quadratic, okay, quadratic function equals to 1 minus x squared. So can you imagine, okay, what is the x z projection? As z projection, it means you view this structure from this side, so you will see this curve, right? And this curve is actually represented by the quadratic function, this one. Okay, so same thing, you can use the vertical or horizontal strip technique in order to define your interval. So in this case, okay, your x interval will be from, so this is your x and this point is 1, right? 1. So your x will be from 0 up to 1, and your z, okay, it will be from 0 up to the equation of the curve. 0 up to the equation of the curve, which is 1 minus x squared. Okay, so now we have to define the interval for y. Okay, interval for y. Okay, so you imagine yourself is sitting inside, and when you refer down, okay, you will see this plane, okay, at the height y equals to 0. So when you refer up, you will see this surface. Okay, so I will label this surface by using different colors. You will see this surface, right? Okay, you'll see this surface, and this surface is actually a portion that is cut by plane y equals to negative x plus 1, right? Okay, so this is the surface cut by y equals to negative x plus 1. So your y, okay, in this case, okay, your y will be from 0 up to negative x plus 1. Okay, so if you arrange the interval here, so number staying outside, so after that you will have your z here, 0, 1 minus x squared, and then after that you will have your y, 0 minus x plus 1, and this one represent the interval for y, and this represent the interval for z, and this represent the interval for x. So you can solve this one. So if you compare this triple integral, okay, by using the z-axis projection with the triple integrals, okay, that you got by using the xy projection, actually their intervals are the same. Okay, almost the same, just the arrangement is slightly different because you choose the z-axis projection. So of course, if you do the integration, you also get the same result, 5 over 12 unit cube. So you can try out yourself.